going to work through these 6 starter questions. I'm going to explain them to the best of my ability, hopefully make sense of them. And then after that, we can look at the main part of today's lesson, which is looking at lines of an equation, y equals mx plus c, looking at how we calculate the gradient and understand the intercepts and so on and so forth. Okay, so Charlotte thinks 27 is a prime number. Explain why she is wrong. Okay, so I'm going to use Tom's example here because Tom mentioned in his explanation on Desmos, he put because it can be divided by 3 and 9, which is exactly right. If a number can be divided by other numbers other than 1 and itself, then it can't be prime. So a prime number, such as 27, can be divided by 1 and 27, but also 3 and 9. So it's got 4 different factors there. A prime number only has 2 factors. So in the chat, can you guys tell me some prime numbers? Just off the top of your head, hit me with some prime numbers. Can be any that you can think of. I'll make sure that they're correct so we can. But I want hit me some prime numbers. So 27, it isn't prime because 3 and 9 go into it. What other prime numbers can we think of? 5, James, excellent. 5 is a prime number because 1 and 5 are the only numbers that multiply to give 5. Go on, let's have at least 2 more. 5, excellent, James. Sorry, prime, yes. 3, excellent. And 3 happens to be my lucky number. So that's something I remember quite comfortably. And then 2. I like the fact you've gone for 2. 2 is the only even prime number. So the number 2, it is even, but it is prime because the only numbers that multiply to get to it are 1 and 2. 7, excellent. You guys know your primes, good. Yeah, 1 and 7, brilliant stuff. Okay, right, I've covered that. I think you guys got that, good. Write down the next term in this sequence. What's happening each time we progress from one number to the next? What is happening? What is the pattern, should I say? What is the pattern with those numbers? As you type in the chat, I'm going to drink. What's happening? How do we get from 2 to 6? How do we get from 6 to 18? How do we get from 18 to 54? Also, Tom, this is not actually an nth term sequence because the difference between these numbers is growing exponential, like it's exponential, it's getting bigger and bigger and bigger. So the gap between 2 and 6 is 4, but the gap between 6 and 18 isn't 4. I like what you're thinking. You spotted the first gap. That is +4, but 6 add 4 isn't 18, so that would not work. +4 does not work. So we need to go back to the drawing board. How else can we get from 2 to 6? How else can we get from 2 up to 6 instead of adding 4? What do we reckon? I'll give you a clue. We multiply it by something. So addition and multiplication, 2 methods we can make numbers bigger. Like you see, a lot of you on Desmos have left this. So it's being multiplied. How do we get from 2 to 6? Well, we times it by 3. And then we can see, right, will that times by 3 work for the next bit? 6 times 3. Does that give me 18? Yes, it does. 18 times 3 also gives me 54. So the rule is to times by 3. And as Louise has mentioned in the chat, this is a geometric sequence. So geometric is where the numbers get bigger and bigger each time because you're multiplying by the same. Okay, so you're multiplying. I'll put in brackets there, multiply, because that's a key word. Okay, so 54 times by 3 will give me the next term. So I'm going to use a little grid method here. So 50 and 4 and then 3. Okay, 3 times 5 is 15. Chuck a 0 on. 3 times 4 is 12. Add those 2 values together. So 150, add 12. Let's do that properly. Let's not be lazy. 0 add 2 is 2. 5 add 1 is 6. 1 on its own. So we should have 162. Now, I'm not going to be picking on anyone here because we all left that one blank. So yeah, when we're trying to spot a pattern, think, how do we get from that number to this? How do we get from the first number to the second number? Okay, how do we get from there to there? Think of it. So Tom mentioned +4. Then check, well, does +4 help me get from here to here? And if it doesn't, then it's not going to be the right pattern. So you've got to go back to the drawing board and think, right, well, how else can I do that? And then hopefully you'll stumble across the right success. But yeah, there we go. Practice with those. I'll chuck a few more of those at you in lessons, just to keep you on the balls of your feet, keep you on your toes. Okay, this one. I like these questions. I did these over Easter in our online revision sessions, so hopefully you attended them, they're not too disfamiliar. When you simplify algebra like that, you need to put all of your groups together. So you need to put all of your M's together and all of your P's together. And the smoothest way of doing that is by grouping them, okay? So 4M and then minus 2M. And the reason why I'm including the symbol to the left is because that's my instruction, essentially. That's telling me what I need to do, okay? So 4M minus or take away 2M. That's going to leave me with 2M because 4 take away 2 is 2, okay? Now, once I've done that, I can focus on my P's, okay? So let's highlight my P's in green. And I honestly encourage you to do this in your exam. With your exam questions, circle them, bubble them, colour them in, highlight them, whatever you need to do. So you can see quite clearly your M's and your P's or your X's and your Y's, so you know that they're separate, okay? So I've got 6 plus 4. Well, that's going to give me 10. So it's going to be 10p. Ta-da! 2m plus 10p. Okay? That's how we do it. We group our things in terms of their collectiveness, okay? There are only red sweets and green sweets in a jar. The ratio of red sweets to green sweets is 2 to 7. What fraction of the sweets are green? So here we have the ratio of red sweets to green sweets is 2 to 7. So 2 to 7. I'm going to write this out a little bit bigger, 2 to 7. And it's red to green. So R to G, red to green, okay? What fraction of the sweets are green? So I want my answer as a fraction. So there's my fraction line, boom, straight in there. What is the total? Right, so ignore how many sweets could be in the jar. Let's just focus on the number of parts of the ratio. What is the total number of parts in the ratio? Looking at that, 2 to 7, what is the total number of parts? 9, excellent. 2 add 7 gives me 9, so there's 9 parts in total. So the bottom of my fraction is going to be 9. It's going to be out of 9. Now it says, what fraction of the sweets are green? Now, this is why it's quite good sometimes to label the ratio. Can you see I put a little g there? So I know green is the 7. So I know there's 7 out of the 9, or 7/9, sorry, of the jar are green sweets, okay? There could be more than 9 sweets. There could be 18, 20, whatever there may be. But I know 7/9 of them are green, okay? So that's how we convert a ratio into a fraction. We put the totals together to get the total bottom number, and then we select the number we need to give us the top number, the numerator. Okay, Maddie's salary is £16,000 per annum, which means year. So per annum means each year, just in case you are wondering. And she's due to get an increase of 5%. Okay, how much will this increase be? So let's have a look at the increase. So we need to work out the increase. And we're told the increase is 5%. So really what I need to do is work out 5% of £16,000. Okay, step 1. What are you guys going to do in this question? You're sat there, been given this question about Maddie in an exam. What's your first thought? What is the first line of calculation you do? What are you thinking, guys? Waiting for you guys. I know there's a lot of pressure on you guys because there's a lot of students on work experience, but yeah, find 10%. I always think finding 10% is a really good place to start. So find 10%. Now, a smooth and effective way of finding 10% with a number that ends in a 0 is by removing the final 0, okay? So that leaves me with £1,600, okay? That's 10%, but we want 5%. So we actually want half of that, don't we? We want half of our 10% value. So what I'm going to do is half 1,600, which gives me £800. So the increase is £800. So she's going to get paid an extra £800 per year. Now, I think the question wants to know just 800, but if it says how much would her new salary be, you take that 800 and then you'd plonk it on top of her original salary. Okay, so it depends on the question. Sometimes you may need to do that one extra step. If you need to know the new salary, you would then take that 5% and then add it on. If you just need to know the increase, then you can probably just leave it at £800. Okay, final bit, and then we'll get stuck into the main part of the lesson. Write down the coordinates of A and then write down the coordinates of B. So when you're utilizing coordinates, you go along the corridor and then up the stairs or down the stairs, okay? So we go along to 2. So the first bit is going to be 2. You can see 2, and then we go up to 3. So it's going to be 2, 3. Along 2, and then up 3. Perfect. Okay. Now here we're going back 1, so it's going to be -1, and then we're going down to -2. Okay. So -1, -2, boom, there is B. So along the corridor, up or down the stairs. That's the best way. I've remembered that strategy, that explanation since day 1. So hopefully you guys have utilized that. But I'm just looking through Desmos now, and you guys are pretty comfortable with you plotting your points. And remember, we've done this in the past in class where we did linear sequences, linear graphs, and you guys were phenomenal. So I'm not going to spend too much time on that. We're now going to get into the juicy bit of the lesson, okay? This bit here, finding midpoints, finding gradients, and then if we have enough time, hopefully we can look at using an equation of a line to help us understand the gradient and the y-intercept as well. Okay, so let's just get stuck into it. Let's just go. So find the midpoint of a line from a graph. So this is actually quite a nice visual topic. Okay, if it's on a graph, it's very visual. And essentially you will have a line like this, A to B. And I can see this line, it goes kind of across 4, up 4. So 2 across 2 up. Here is my midpoint. I can see quite visually that is exactly halfway. Now, midpoint, let me just make sure we understand what midpoint means. It means halfway. So essentially, we want to cut that line perfectly in half. So I can see at that point there, okay, it's been perfectly midpoint, perfectly halfway. So 3 across, 3 up. So the midpoint for that graph is 3, 3. Okay, nice. Happy with that. Next one. Can we just appreciate how smooth that transition is? Can you? I don't know, it's probably not very smooth on screen, but that is, I didn't know I did that. Right, next one, A and B, another line. We need to find the midpoint. So once again, very visual. Let's see, I think that is my midpoint there. 2 across, 3 up, 2 across, 3 up. Yeah, perfect. That is exactly the midpoint. So once again, we go across 2 and then up 3. So it's going to be 2 to 3. That is my midpoint. Very visual, this. There is a strategy to show you in a second where it isn't visual and you can use numbers, but I think students, when it's visual, find it a lot easier. So yeah, like for example, if I put it there, you know that that is not the midpoint. And if I put it up here, that is not the midpoint. So use your eyes and just check, yeah, is it roughly in the center? Yeah, and you could even use a ruler, arguably, measure the line and then halve it. That could also work. Obviously, going to be hard to do that online today, measuring a line on the screen, but yeah, you get the gist. Okay, so there's my midpoint. Happy days, 2 to 3. Next one, let's have a look at this one. This one here. Oh, this one's probably the nicest one of the bunch. Okay, I can see bang on. There's my midpoint right there. No messing around with that one. And then once again, go across and then go up. So 3 across and then 3 up. Happy days. They're my midpoints. Now, you may get a question where it doesn't give you a line. And now you think, well, how do I find the midpoint of a line when I've not been given a line? Okay, well, what you do get given is a pair of coordinates. And those coordinates are essentially these things here. Okay, So that would be one coordinate, that would be another, and then you draw a line between them. Now, you may not be given a graph paper, you may struggle at this point. You might be like, well, I've not got a graph paper, I can't see a line, what do I do? Dead nice strategy for this, okay? You add up the coordinates and then you divide it by 2. Because to find half of anything, of any two things, add them together and divide by 2, okay? So let me show you what that looks like in action. Let me change the colour of my pen to red so it stands out a little bit. So we've got 2 to 4. I'm going to add that. I'm going to do a little addition. I'm going to add that to 6 to 10, okay? So that's 2 add 6, okay, gives me 8. And then 4 add 10 gives me 14. Now, once I've done that, I need to do one final thing. I need to divide it by 2. I need to half it to give me my halfway point, okay? So half of 8, whoops, let me write. There we go. Let me fix my pen. There we go. 8 to 14. Half of 8 is 4. Half of 14 is 7. And then just like that, I've got my midpoint. So add them together and then divide by 2. And we'll do another 2 examples of this, I believe, on the PowerPoint. And then I get you guys to give it a go, okay? So if you don't get given a line, add the 2 coordinates together with your column addition, like I've done here. Add them together, and then remember to divide it by 2, okay? Do one more example. Ooh, got some negative numbers. Juicy. Okay, so 10 and 2. We're going to add -5 and -4. Because remember, with coordinates, they can be negative. They can be on the left side and on underneath a graph, can't they? So 10 add -5. 10 add -5. Well, 10 is a positive number, and we're adding a negative. So it's going to go down. So it's going to go down to -5. Okay? Now, 2 add -4. So 2 is a positive number. We're adding a minus. It's going to go down by 4. So it's going to go down to -2. Okay? So there's my new set of coordinates, or my new total. I now need to divide it by 2. So let me write that up here. -5, -2. I'm going to divide that by 2. So half of -5 is -2.5. Okay? And then, I don't know why I put a bracket there. And then half of -2 is -1. Okay? And that gives me my midpoint. I know it sounds a bit bizarre, especially when we're dealing with negative numbers, but that's it. So add them together and then divide by 2. Let me just finish highlighting that. So add them together and then divide by 2. And you'll get some nice numbers sometimes. You get some positive coordinates, but you may get some nasty ones. So just be prepared for that. Okay? And then here we go. We've got some positive numbers here. So 9, 8, and then 4, 8. You'll notice I'm going to add them together. 9 add 4 is 13. 8 add 8 is 16. Once I've done that, I divide by 2. So I half 13 and I half 16. Well, half of 13 is 6.5. Half of 16 is 8. There we go. Now, I'd like to show you this, like in terms of having a graph to quickly colour in and draw in, but I've not got that on the PowerPoint, unfortunately. You're just going to have to take my word for it, that these are indeed exactly halfway across those lines. If you've got a graph paper, you want to draw a graph, feel free, because I'm confident 100% that is the right answer, okay? So from a pair of coordinates, just add the coordinates together and then divide it by 2. This is the bit where I pass on the mantle to you guys. I would like you to work out some midpoints from a graph and then also from a set of coordinates, a pair of coordinates. So back onto Desmos. This is the bit where you guys can show them what you can do. And then just work through them as best as you can, okay? Nice selection there, the multiple choice. So work out your answer and then check if it is in that selection of multiple choice answers, okay? Don't just circle one that you think looks right. Do the maths, get an answer, check it's there. If it's there, happy days. Okay, right, I'll be back soon, guys. Good luck, show me what you can do. Wait a little bit longer, guys, for you guys to finish off those questions. But yeah, get stuck into it, show me what you can do, okay? Darcy and Grace, excellent for question 1, looking good there. And then select a multiple choice answer for your other bits. Okay, 2 more minutes, just so you can check your answers as well, okay? Okay, right, bring your attention back to the PowerPoint, but impressive answers, guys, on decimal sign. Generally impressive means you either have this in your locker already or you've been listening carefully and you've got the gist of it. So, right, there are brackets. So, well done if you've remembered to put brackets into your answer on Desmos. However, don't worry if you haven't, because in the exam, you'll be given the brackets to fill in or already. So, A to B. Now, most of you were pretty accurate in spotting. It is 3 across and then 3.5 up. Okay, 3 across, excellent, and then it lands in between 3 and 4, so that's 3.5. Once again, it might be one of them where you have to get quite close. Now, we have just, also looked at the fact you can just potentially, and I'll show you this actually. Can you see here, we've got the 2 points. This is a good point, actually. I can prove my maths. Okay, are you ready? So even if you don't like the line on the graph, and you're like, nope, I want to do it with numbers. Let's have a look. So 0 and 2, and then 6 and 5. Add them together. Well, that gives me 6 and 7. Divide that by 2. Well, I get 3 and 3.5. It works. Yeah, so even if you're like, I just want to double check my answer, you've got the ability to do that. If you know the coordinates, which you can work out, okay, you can then double check your answer. So it's always good in maths to be able to check your answer and be confident, knowing that you can leave the exam knowing you've got those marks, okay? Next one. So here, look, there's no line. So what do we have to do? We have to add up these numbers and then divide by 2. So 2 and 13, 10 and 1. Add those 2 bad boys together. So that's going to give me 12 and 14. What do I do with that? Divide it by 2. Okay, that's going to give me 6 and 7. Now, you'll notice I've not even looked at the answers up until now. Now I'm looking if 6 and 7 is on there. Nope, nope, yes. So that really does back up my conscience in that I've got it right. Okay, it really makes me think I've got that because I've worked it out and the answer that I've got is there. If I got an answer of like 3, 7 and 3, 7 isn't there, I'd be like, hang on a second, I've done something wrong. Yeah, so good. 6, 7, happy days. Next one. Once again, ignore, look, these answers, they're not there. Okay, ignore them, okay? Right, 4, 9 minus 2, 1. Okay, 4 add minus 2, so that's going to go down to 2. 9 add 1 is 10. What do I do now? Divide by 2. So that's going to be 1 and then 5. Okay, right, let's reveal those answers again. 1 and 5, look at that. Look at that, beautiful. Thank you, sir. Give me that 1 mark. On to the next one. So add them together, divide by 2. If it's a multiple choice answer, it's only ever really going to be 1 mark. Okay. However, given the fact it involves 2 steps, addition and then a division, it could be worth 2 marks if it's open-ended. So hopefully, with your ability and your skills, you can get it, and it's a nice one to have. Right. Once again, 2, 12. Add 8 and 2. All right, add them together. 10 and 14. Divide it by 2. 5, 7. Is that on there? Yes, it is. Okay, I thought we had the same answer as before. We didn't. That was 6 and 7. This one, 5 and 7. Happy days. So guys, always just work out the answer and then just check. Is it in the answer line? Is it in the answer selection box? If it is, happy days. Right. That is how you find a midpoint of a line, when you get given a line or when you get given coordinates of a line. Lots of practice. Well, I can chuck some of those at you quite comfortably in the future. Don't worry, I will do that and keep you on your toes with that. But this is coming up on paper 2, so we'll do that nearer the time. We are now going to look at gradients. Can anyone tell me what a gradient is? Like, it's a mathematical word. If we were to explain it to a young child, like, you know, and they're like, what does gradient mean? How would you try and describe what the word gradient means? Because understanding what gradient is helps you understand what you're looking for on an exam paper, essentially. Okay, so what is gradient to you guys? I'll give you a moment to type in your suggestions. It's all gone quiet. It's all gone quiet. I'll tell you what, it's the first lesson back after Easter. I'll let you off. Gradient is how steep something is, okay? So if it's got a very high gradient, it's very steep. If it's got a very small low gradient, it's not very steep, okay? So a gradient whereby it's like 0.01, very low. It's only going up a little bit each time, okay? If it's like 10, it's going up quite drastically every time, okay? So gradient is how steep something is. Now it says here, C is where it crosses the y-axis. That's known as your y-intercept. So on a graph, a line crosses through the x-axis and the y-axis, okay? The C represents where it crosses the y-axis, okay? The gradient is how steep the line is, and the C represents where it crosses the y-axis, okay? Make a note of that. Hopefully you guys have, because that's quite crucial. And Louise, if you're able to screenshot that, that would be good to put in the chat, because that's something that they can refer back to throughout. There we go. Really important that we know y equals mx plus c. M is the gradient, c is the y-intercept. Excellent, there it is. It's in the chat, so you've got that there. Okay, what is the gradient? Well, thinking back to what we've just looked at, gradient is always the letter before the, always the number before the x. So the gradient is 3. Done. So all I needed to show or prove is that I know that the number before the gradient, before the x, is the gradient. So 3, which is the y-intercept, it's going to be 4. Okay, it'll cross x-axis at the 4 coordinate 4, essentially, if that makes sense. Okay, so that's me understanding this equation and then being able to, you know, decipher, work out the gradient and then the y-intercept. Okay, now let's have a look at this one here. What is the gradient? It's the number before the x, so it's 7. What is the y-intercept? -4 this time. Okay, the reason why before it was just 4 is because it's a positive number, so it's just going to be 4. If it's a minus, it means it will cross the y-axis at -4, so underneath the x-axis. Okay. Now, you may get a question like this. So remember originally, it was y equals mx plus c. This one's slightly different. Why is it different? Because it's now saying 3y. So how can I get 3y equals 15x plus 9 how can I get that into a format where it's y equals mx plus c? How can I change it? I'm going to tell you actually, because it might be a bit nasty to chuck you in at this point. You divide it by 3, because if you divide it by 3, that's going to leave y by itself, and that's what we want, isn't it? We want it to be y equals. But if you divide this side by 3, you have to divide these by 3 as well. So 15x divided by 3 is going to give me 5x, and then 9 divided by 3 is going to give me 3. So now, instead of it being awkward, where I've got a line that's been multiplied, I've now got it in its simplest form. Y equals 5x plus 3. What is the gradient? The number before the x. What is the y-intercept? The end digit, the end number, so 3. Okay, so that involves one extra step. We need to be smart there. Like, that's 3y. I just want it to be y, so I need to divide by 3. So now thinking on that, what do I do with this? First things first, what do I do with this? I'm going to write it up here. I've got 6y equals 12x plus 30. What do you think I should do, guys? First thing. Suggestions are welcome, because you guys are going to get stuck into it in a bit. Divide by 6. Excellent. Excellent. I like that, Darcy. And I'm going to do it in black ink just to make it look different so you can see the working out step. So divide by 6, divide by 6. Okay? So that's going to leave me with y equals 2x plus 5. And now I know that, I can then use that to help me work out the gradient and then the y-intercept. So the gradient is always the number before the x. So in that case, or in this case, it is 2. Okay, the y-intercept is the final number at the end of the equation, and this one is 5. Now, if it was a minus 5, the y-intercept would be minus 5, but as you can see, it's plus 5, so it's just simply 5. So done. Okay, now you guys show me what you can do, and you'll see there's a lot of multiple choice ones here. Once again, work out the answer, check if your multiple choice number is there. Okay, get stuck in, show me what you can do. I'm going to paste it now so you can get onto the right page on Desmos. Excellent. Okay, right, guys, get stuck in. There's another link in the chat to Desmos. Off you go. I'll leave my working out on the screen to help you with some of the more tricky ones. Yeah, y equals mx plus c. Let's master that today, have it in our locker, and pick up those marks in the exam on paper 2. Okay? Okay, I'm observing the finale of the questions. I see Tom and Grace have got an answer in, so make sure everyone else you putting your answers in just so I can check progress. If you finish, just pop in the chat, say done. It's a really nice way for me to see quite clearly who's ready to move on, who's ready to review the questions. If you have finished, check your answers. Make sure you've not made any silly mistakes. Yeah, you've not accidentally done this or accidentally done that. Yeah, let's get into good habits now. So like, even now, I'm looking at my screen like, yep, definitely got those numbers right. That's fine. You just got to always be thinking, have I done that right? Don't just do something once and think, yep, nailed it, because it may be something simple, but if you get it wrong, it could cost you some marks. We want to get as many marks as we can. Okay, I'm going to go through these questions. So I want you to bring your attention back to the PowerPoint and we'll review them together. So what is the gradient of the line? So the gradient is the number before the x. So that's a 4. It's a positive number, so it's going to be 4. What is the y-intercept? Well, the y-intercept's still a bit at the end, so it's going to be -5. Excellent. And you can see how the examiner tries to catch you out by putting in a +5 and whatnot. So always be clear on the symbols. If it's a positive number, give a positive answer. If it's a negative number, negative answer. Okay? The equation of a straight line is 2y equals 3x plus 5. 2y, that doesn't sit right with me. So what do I have to do? I have to divide it by 2 to get it simply down to get it as low as I can go down to y equals, okay? So divide it by 2 all the way throughout, divided by 2, divided by 2. Now, that's going to give me y equals 1.5x and then plus 2.5. Now, I'm looking, because I want the gradient, and the gradient is the number, let me change that to yellow. The gradient is the number before the x, so 1.5. Okay, now there's not a 1.5 on there, but do you know what I can do? I can definitely get rid of 3, definitely get rid of 5. Now I'm left with these two fractions. Now I need to convert 1.5 into a fraction, but what we've done here is we've done 3 divided by 2, which we can write as a fraction as 3 divided by 2, which then helps me establish it is that. And I'm hoping some of you will like have the know-how. 2 divided by 3 would give you a number less than 1. It actually gives you 0.6 recurring, so it can't be that either. Okay, so allowing you to work out the answer allows you to cross off some definitively wrong answers, leave you with a selection which allows you to apply some other mathematical understanding too. Okay, and then the final one here, circle the gradient of the line. Ooh, ooh. Look at this. This is clever. This gradient of the line is always the number before the x. What do we have before the x? We have a -2. That is saucy. That is proper saucy. That question worth a mark as well. How many people got cut out? I got caught out by almost. I almost circled 6 because I'm so used to it being the first number. But it's only the number before the x that we care about. Okay. So that's something we need to be aware of. Now, do you know what's really good, guys? The fact you are here and you're listening or you're watching this after the lesson, you'll be aware of that. You will not be caught out by that, hopefully. Okay? Shows you the examiners try and catch you out. Okay, the last thing we're going to look at today, and I know probably another 10 minutes or so, is finding the gradient of a line when it's given to you on a graph. Okay, and this in gold or yellow, or crunchy color, I don't know, it's up to you guys, whichever you want to describe it. That is the golden formula. It's how far up the line is divided by how far across it is. So how far up? So I think probably sometimes the nicest way to do it is just to count. So it goes 1, 2, 3, 4, 5, 6 up. So it goes 6 up, and we divide that by how far across it goes. So it goes across 1, 2, 3. Okay, and we can check here 1, 2, 3, 4, 5, 6 up. Yeah, 3 across, excellent. So it's going to be 6 divided by 3, which is 2. The gradient is 2, okay? Now, let me just get rid of these lines that I've doodled on. Now, my answer is 2. So that means for every 1 across, I go 2 up, the steepness, yeah? So every 1 across, I go 2 up. So let's see if that works. 1 across, 1, 2. Yeah, it works. 1 across, 2 up. Yeah, 1 across, 2 up. Yeah, it works. So 1 across, 2 up. The gradient is 2. So how far up the line goes divided by how far across it goes. Okay? Let's do some more of these. So how far up? How far up? And if it helps, write down up and across. Up divided by across, like so. All right, up. 1, 2, 3. So it goes 3 up, across. 1, 2, 3, 4, 5, 6. 3 divided by 6 is 0.5. So for every 1 across it goes up half a square. Yeah, goes up half. Yeah, I can see that. So up divided by across. Up divided by across. Let me make that a bit neater. But you can see I'm drawing on the piece of paper. I'm making it very clear to myself. It's up divided by across. And I'm getting the right answer every time. Go one last one. Okay, so you got given the coordinates here. Now, when you got given the line, just focus on very visual. You can just make your life a bit easier. So how far up? So it goes from here all the way up. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So up equals 9. I'm going to divide it by across. Let's have a look at across. So it goes there. So 1, 2, 3 across. 9 divided by 3 gives me an answer of 3. The gradient is 3. So for every 1 across, I go 3 up. And I can look at that in action now. Let's see if I'm right. So let's go here at the bottom. 1 across, 1, 2, 3 up. 1 across, 1, 2, 3 up. Yeah, perfect. 1 across, 1, 2, 3. Yeah, it works. Okay, so that's a really good way to check. Just 1 across, 3 up. Perfect. 1 across, 2 up. Perfect. Okay, 1 across, 0.5 up. Bit difficult when you're dealing with decimals, but hopefully you can see it. Okay, very visual. Now, this is the last bit of the lesson. I want you guys to work out some gradients of a line. Okay, the last bit of the lesson. How far up the line goes divided by how far across it goes. If you can do that, you finish this lesson on strong, buzzing. You've nailed it. You've picked up on intercepts, gradients, midpoints, and you're picking up your self-marks on an exam. Okay, so I'll be quiet. I'll let you focus. I'll leave an example on the screen, and then, yeah, I'll be quiet. Off we go. So you guys have got, by the looks of it, 2 graphs to work out. So 2 gradients. How far up divided by how low down. Now, the second graph, particularly, I'd say difficult because you've got large units to work with. Feel free to use a calculator because this would be on a calculator paper, so you can make your life easier. Okay, if you're struggling, that's fine. I understand. It's something we've not looked at before. Make sure you listen to my explanations carefully. Hopefully they help. And if not, treat this as a topic to work on. You can watch YouTube videos. You can speak to your face-to-face teacher. If it's different to me, speak to go on Sentry, anything. Because it's coming up. We know it is. Gradients of a line. We need to practice it and make sure we're comfortable with it. Okay. Ooh. Let me just scroll down, refresh the page, make sure we've got some answers to work with. We have a few different answers, which is fine. We'll see who's got it right and who's got to do a little bit more practice. Right. So this question here says a straight line drawn on a centimetre grid. Faye assumes that the scale is 1 centimetre represents 1 unit. Okay, use your assumption to work out the gradient of the line. So although it doesn't have numbers on the side, we're going to assume it's 1 centimetre or 1 space is 1 centimetre. Okay, so we need to do the difference between height divided by difference across. So up divided by across. Okay, so how far up does it go? So it starts there, ends here. So it goes 1, 2, 3, 4 up. So it's going to be 4 divided by how far across it goes. So it goes all the way across this grid, doesn't it? So 1, 2, 3, 4, 5, 6, 7, 8. 4 divided by 8 will give me 0.5. So the gradient is 0.5. Okay. Now, this isn't on the question, but if it said, what is the y-intercept? Okay, the y-intercept is this bit here, where it would cross the y-axis. So it's not a question. However, I thought, let's just quickly discuss it. That would be the y-intercept. And assuming that each one of these points is worth 1, then it would be 1, 2. So the y-intercept would be 2, okay? Because I think we've talked about y-intercept, but I've not shown you what it is. The y-intercept is where the line would cross the y-axis, which is here, okay? This line here, so this is the juicy one, because look at these numbers we've got to deal with. So remember, it's difference between the up, how far up it goes and how far across. So 80 to 200. So here, really, you could, instead of having to count, you could use a bit of quick maths. So we need to work out the difference between 200 and 80. So 200 take away 80 is 120. So that's how far up it goes. And then across, it goes from 0 all the way to 60. So if I do 120 divided by 60, that gives me 2. So it has a gradient of 2. So for every 1 across, it goes 2 up. But that is different to the examples that I had. So if you struggled on that one, don't beat yourself up, because that is one that we've not done yet, or you haven't seen yet. But yeah, difference between these two, which is 120, and then the difference between these, which was 60, based off of their coordinates and the values at the bottom, okay? Difference between top and bottom divided by across, okay? Now, we're going to leave it there. I know this is a topic that we will benefit from doing in the classroom. So I'm going to try and find some exam questions that we can put into a little starter maybe on Friday. And then I can help you guys just practice drawing on the sheets, making notes, reinforcing what we've done today before we get stuck into the main course on Friday. Okay. Right, guys. we'll call it a lesson there. Thank you for sticking with me throughout. I appreciate that. Hopefully you didn't find it too bad. Hopefully you've learned a few new things there. I have recorded this. I will put it onto YouTube because I'm cool, and you can watch it back in the future for revision if you wish. Okay, guys, it's been a pleasure as always. So enjoy the rest of your day. I'll speak to you all soon and see you all hopefully on Friday, if not next week. Okay, catch you guys soon.
Hi Sam, sorry I got cut off at the end of that.
It's okay. I was going to stop.
I'm in the library.
It's okay, yeah, no worries. It was interesting because there's how few students we had there.
Yeah, it's just suddenly going. I'm still trying to get on. I'm just on my phone now, just hearing this. Yeah,